Here's something that shouldn't work. One of the fastest databases on the planet runs your commands on a single thread. Just one. No cores fighting over locks, no thread pool, one loop handling everything in order. And on ordinary hardware, it still clears 1 million operations a second. That's Redis. It lives in memory, it talks in data structures instead of tables, and it's almost certainly sitting behind the app you shipped this week. By the end, you'll know why one thread is a feature, not a bug. How Redis survives a restart, what breaks when memory fills up, and where its speed quietly lies to you. I'm at pattern repetition. Let's get into it. So, what is it? Redis is an in-memory data store, but that sells it short. The docs nail it in 4 words. Redis is a data structure server. No rows, no columns. You get strings, hashes, lists, sets, and more, all living in RAM, ready in microseconds. Start with the strange part. How does one thread serve thousands of clients at once and still feel instant? The trick is an event loop. Redis never sits blocked waiting on one client. It leans on the operating system to watch thousands of connections at once, then serves whoever's ready. Every turn of the loop, it flushes pending replies, asks the kernel what's ready with a call like epoll, runs those commands, fires any timers, and loops straight back. One thread, always busy, never waiting. Here's the catch that bites people. If every command runs on that one thread, one slow command blocks all of them. Run KEs across 1 million keys in production, and the whole server freezes for everyone. So the rule is simple. Keep commands short and watch the slow log for the ones that aren't. It isn't purely one thread anymore though. Since version 6, Redis can push the network reads and writes onto extra I/O threads. And Redis 8, out in May 2025, rebuilt that from scratch. With 8 I/O threads, it measured up to 112% more throughput than 7.2. But the core promise holds. Your commands still run one at a time in order. Only the plumbing went parallel. That one thread guards a toolbox most people never fully open. Let's see what's inside. 6 core structures do most of the work. Strings for cached values and counters, hashes for objects, lists for queues, sets for unique membership, sorted sets ranked by a score, and streams an append-only log of events. Different shape, different job. Start simple. A string holds anything. Text, numbers, a JPEG, a serialized object, up to 512 megabytes. Set a value, read it back in microseconds. And because Redis runs every command atomically, incrementing a counter is one safe step. No read, add, write, race to lose. That single command is how half the internet counts things. Sorted sets are the one people fall for. Every member carries a score, and Redis keeps the whole set ranked for you. Add a player's points, then pull the top 3 in a single call, already in order. Both the add and the ranking are logarithmic times, so it stays quick with 10 players or 10 million. Almost every leaderboard you've ever seen is a sorted set underneath. Which is the whole point of that 4-word definition. Redis is a data structure server. You're not cramming everything into strings and hoping. You grab the structure that fits the problem, and the hard part is already solved. Everyone quotes Redis speed numbers. Almost nobody quotes the conditions. Let's fix that. On Redis's own benchmark, one node, no pipelining, tiny values, a plain write lands around 180,000 a second. A list push, about the same. Load a heavier scripted command though, and it falls to 70,000. Same server, same hardware. The command you run decides the number. Now switch on pipelining, batching commands, so you stop paying for network round trip every single time. That same box streams over 1.8 million reads a second. A typical write comes back in roughly 1/7 of a millisecond, and the event loop has been pushed past 60,000 live connections while still serving 50,000 second. But be honest about where the real ceiling is. The Redis docs say it plainly. In the real world, throughput is usually capped by your network long before the CPU runs out. That million ops a second is genuine. Most days you'll hit your wire speed first, which is why you scale out with more instances, not up with one giant node. Now the uncomfortable question for a memory database. What happens when the power goes out? Redis gives you 2 roads onto disk. Snapshots called RDB, fork a copy of the data and dump it, Compact, quick to reload, but everything since the last snapshot is gone. Or the append-only file AOF, which locks every write as it happens and replays that lock on startup. Snapshots are cheap and lossy, the lock is durable and heavier. With the lock, you choose how paranoid to be. Fsync on every single write is the safest and the slowest. Fsync never, and you're trusting the operating system to flush when it feels like it. The default sits dead center. Fsync once a second, so your worst case is losing about 1 second of writes. Almost everyone lives right there. 2 things worth knowing. Taking a snapshot forks the process, and on a large data set, that fork can stall Redis for a fraction of a second. And these two aren't a choice between. The docs recommend running both: snapshots for fast backups, the lock for point of failure recovery, belt and suspenders. Everything lives in RAM. So the scariest question is the simplest one. What happens when you run out? You set a memory ceiling, then tell Redis how to react when it hits it. By default, it does the unfun thing. It refuses new writes and returns errors, which is exactly right for a real database. For a pure cache, let it evict, usually the least recently used key. And if you're mixing cached and permanent data in one instance, only evict the keys that carry an expiry. 2 details that surprise people: that least recently used eviction is an approximation. Redis samples a handful of random keys, 5 by default, and drops the best of the batch, not the true global loser. Push the sample to 10 if you want it sharper. And expired keys don't vanish right on time. Redis clears them when you next touch them, plus a background sweep about 10 times a second. One node is a single point of failure. Here's how Redis stops being one, and the bill it hands you for that. The foundation is replication. One primary takes the writes, and replicas copy everything it does, so you've got live spares and somewhere to send your reads. Plain, and it's the base for everything that comes next. But read the fine print. That replication is asynchronous. The primary confirms your write before the replicas even have it. The docs are blunt about it. There's always a tiny window where a failure can lose an acknowledged write. If a byte truly cannot be lost, Redis on its own is the wrong home for that byte. 2 ways to stay highly available. Sentinel is a set of watcher processes. They agree the primary is dead, then promote a replica on their own. Your whole dataset still fits on one node. Cluster takes the other road. It shards your keys across many primaries, each with its own replica, so you scale past a single machine's memory. Run Cluster and you don't run Sentinel. Cluster doesn't hash your keys straight onto servers. It spreads them across exactly 16,384 slots. A key slot is a checksum of its name, wrapped around to that count. Add or drop a node, and you just hand off some slots. That one fixed number is why resharding never has to rehash the entire world. Enough theory. Here's what people actually build with all of this. Redis turns up in the same 5 jobs over and over. Caching, so reads never touch your database. Rate limiting, leaderboards, job queues, and pub sub for broadcasting events. One little server, 5 completely different heads. Rate limiting looks trivial and hides a real bug. Increment the counter for the user, set it to expire in 60 seconds, done. Except if your process dies between those 2 commands, the counter never expires, and that user is throttled forever. The fix is to run both as one tiny Lua script. Redis runs it atomically, so nothing slips in between. 2 commands, 1 indivisible step. And here's the sharpest edge in the whole toolbox. Classic pub/sub is fire and forget. If a subscriber isn't connected at the exact instant you publish, that message is just gone. No queue, no replay, at most once. When you genuinely need every message delivered, reach for streams instead, which keep the log and let a consumer catch up later. Most people learn this one in production. So the trade-offs line up cleanly. Caching gives you fast reads, but it can hand back something stale. A rate limiter is cheap, but only correct when it's atomic. And pub/sub is instant, but at most once, so it can quietly drop your message. Pick the failure you can live with. None of this appeared overnight. Redis started in 2009. One developer building it for his own startup. Streams arrived in 2018. Then, in 2024, the license changed. The community forked it into Valky, and the drama was very real. And in May 2025, Redis 8 shipped back under an open source license. It pulled search, JSON, and vector sets into the core. 5 things to actually take with you. Keep every command short, because one slow query freezes the whole server. Turn on the append-only file if losing data would hurt. Set a memory limit and an eviction policy before you ever need them. Make your rate limiters atomic with a script, and never trust PubSub to deliver a message that truly matters. That's Redis. One thread held in memory, speaking in data structures, quietly doing 5 jobs behind the app you shipped this week. It shouldn't be this fast on a single thread. It just is. Use it for the right byte and know where it can lie to you. I'm at pattern repetition. See you in the next one.